Hi, I'm Armin, founder and president of RF Digital. Now watch how Simblee is making tomorrow's IoT dreams into today's reality.
Hey guys, this is Aaron from RF Digital with another example of combining Simblee technology with AMS sensors to create a true interface of things. Today, I'm going to show you how to connect and communicate with multiple sensor shields using Simblee and how to graph their data with Simblee for mobile. We'll also take a look at how we can dynamically add and remove sensors during runtime. I have with me the Simblee development kit number RFD77803, the Simblee ams CCS811 starter kit number RFD77809, the Simblee ams ENS210 starter kit number RFD77807, my mobile device, and my laptop. First, let's take a look at the completed demo. Assemble your demo kit with the AAA battery shield and the 7-pin Simblee breakout board, then turn on the switch to power your device. Open the Simblee for Mobile app on your mobile device and select the CCS811/ENS210 device listed. You'll now see the user interface pushed directly from the demo kit to your mobile device. Since both sensors are disconnected, you'll see disconnected listed in both the CCS811 and ENS210 sensor areas on the screen. Now we'll add our ENS210 sensor shield. You can see Simblee instantly detects the sensor is connected, initializes it, and begins reading values in real time. You can also see the advanced temperature gauge and relative humidity graph. Awesome! Watch how the values change and the graphs move when I blow on the ENS210 sensor. Now that's cool. Let's add the CCS811 sensor shield. Like before, Simblee detects the new sensor has been connected and initializes it in real time without a reduction in performance of the user interface or other sensor. That's incredible! Check out these amazing graphs. If I blow on the sensors again, you can see the CO2, volatile organic compounds, temperature, and relative humidity graphs change in real time. Let's take a look at the code. First, we need to include a bunch of header files. We'll include Simblee for mobile to create our user interface, Simblee ENS210 and Simblee CCS811 to communicate with our sensors, and the wire library to provide the low-level communication protocol. We'll also include a bunch of image header files for use in drawing our UI. Then, we'll define image numbers to be used later in the code. Next, we'll create a simple enumeration to help us keep track of what kind of sensor data values we'll be using later. Now, we'll create one instance of both the Simblee ENS210 library and the Simblee CCS811 library. Next, we'll define a bunch of variables which will keep track of the status of each sensor and also the data that we read from each sensor. We'll also need variables to keep track of our Simblee for mobile object IDs, so we'll define those here. Let's take a look at the setup function. We'll begin by starting serial communication and printing a header to the serial console explaining the demo. Next, we need to check if our CCS811 sensor is responding on the I2C bus. Since we'll do this multiple times throughout the code, we'll define a function called checkPart, which will do all the heavy lifting. After calling checkPart, we need to see if the CCS811 sensor responded. If the sensor didn't respond, we're going to set our CCS811 connected variable to false and print a message to the serial console. If the sensor did respond, we'll move forward with initialization. Depending on the result of the initialization, we'll set the CCS811 initialized variable appropriately and print a message to the serial console. We'll also perform the same procedure for the ENS210 sensor shield, checking if it's responding and initializing it if possible. Lastly, we'll set the device name and advertisement data for Simblee for mobile and call simbleeformobile.begin. Now let's skip down to our UI function. To start, we'll need to call our Simblee for mobile.begin screen function. We'll start here with a white background. Then we'll draw our gradient background rectangle. We'll also draw the headers for our CCS811 sensor data and the text elements that will hold the sensor values themselves. Next, we'll draw the graphs to show our CCS811 measurements. We'll draw the rest of our CCS811 objects and then move on to the ENS210 objects. We'll draw our separators, header text, and text elements to display the temperature and humidity values. Now we'll draw our temperature gauge image and the gradient bar that will move inside of it. Next, we'll draw the humidity values and the humidity graph objects below it. Lastly, we'll make sure the correct objects are shown and updated when the UI is drawn. Here you'll notice we used a custom function called getFloatText. This function is defined later on in the code. That's it, we're done with the UI function. Excellent! Next is our checkPart function. We're going to call wire.beginTransmission, send a single 0 byte, and return the byte from the I2C bus. That's it! The getFloatText function is important to convert float values to readable text in the user interface. We're going to use the sprintf function to convert the float, then we'll add the correct values at the end based on the mode argument. This is where that enumeration we created comes in handy. The calc CO2 bar width, calc VOC bar width, and calc temp bar Y functions are pretty self-explanatory, returning the width of the CCS811 graph bars and Y location for the temperature graph, respectively. Let's move on to the calc humidity pointer X function. This function determines the X location of the pointer image by mapping the humidity value to the X pixels. Since the percent bars are smaller above 90 and below 10, we'll need to account for that when determining the high and low pixel values. The next 4 functions make sure that the correct objects are shown on screen correlating to the CCS811 and ENS210 sensor statuses. Alright, let's jump back up to our loop function. First, we'll check to make sure our CCS811 sensor is still connected. If the previous status was connected, but we no longer are, we're going to show the disconnected text and hide the other CCS811 objects. If it is connected and our init CCS811 next variable is set, that means we need to initialize the sensor. This will allow the sensors to be dynamically added and removed during runtime. If the initialization fails, we'll set our variables back to default and move on. If the initialization succeeded, we'll show the CCS811 objects and hide the disconnected and initializing messages. Lastly, if the sensor is connected and initialized, we'll take a measurement and update all of the Simblee for Mobile objects accordingly. Next, we'll repeat that entire process again for the ENS210 sensor, checking for connectivity, initialization, and updating the objects according to the measurement values. Don't forget, we have to call Simblee for Mobile.process at the end of our loop to make our user interface work. That's it! Thanks for joining us as we showed how to combine Simblee's revolutionary technology and the incredible CCS811 and ENS210 sensors from AMS to create an amazing demo. For more information about Simblee, visit the Simblee YouTube channel or www.simblee.com. For more information about the incredible sensing technology from AMS, visit the AMS website at www.ams.com. Thanks for tuning in, and we'll see you next time.